Hello, good morning. My name is Twan Korthorst, and I'm Director Photonic Solutions at Synopsys, and my responsibility is to lead the Photonic IC activities at Synopsys. So let me share my presentation with you and discuss electro-optical co-design challenges. So I hope you can all see my screen now, and today I want to discuss how Synopsys is accelerating adoption of photonic IC technology by supplying solutions for electro-optical and photonic IC design. Before we do that, I really like to thank all the people that made this event possible today, which of course are the presenters that we have been enjoying so far. Aaron, Ben, Ed, Lisa, Rob, Robert, and Samir, thanks for sharing all your views and insights today with us. Really great to learn from you how you view, let's say, this ecosystem developing and what role you are playing at your respective organizations. And of course, I'd like to thank all my colleagues at Synopsys to support and organize this symposium today and tomorrow. Thank you. So Synopsys is hosting this event, and why is Synopsys actually caring about photonic IC solutions? Well, let's first quickly review what Synopsys is today. Synopsys is the #1 electronic design automation company in the world, supplying tools and services to design, analyze, manufacture electrical integrated circuits and systems. But we also supply a very large IP portfolio in interface, foundation, and physical IP. We're actually the #1 supplier of IP in this space as Synopsys. And the third angle that we are pursuing as a company is software integrity and software security. So where systems develop from, let's say, silicon die to complete systems, including a software stack on top of that, we supply tools from the foundry up to validation of the software stack on top. So that's Synopsys today, around 15,000 employees worldwide, 122 offices around the globe. I'm personally located in Europe, in the Netherlands, but as you see, we have a span across the whole globe, supplying services, supplying tools to our customers. And in 2020, we had a revenue of $3.7 billion. And for this year, we're looking at achieving over $4 billion. And Synopsys cares about photonics because after the 19th century of the Industrial Revolution and the 20th century that you could call the Electrical Revolution and Information Era, we see photonics as a key enabling technology to enable systems and devices and circuits to help solving societal needs in data communication, in industrial communication, in sensing and imaging solutions. So for us, it's clear that photonics is and will be a key building block for our high-tech society. And Synopsys, as a traditionally electronic design automation company, recognized early that photonics is different and started to invest in this space by acquisition, by building teams to develop software solutions that help overcome of these key challenges that you see in photonic IC design and manufacture. So photonics is about moving photons around and not electrons. And these photons behave differently. So there is different physics, and therefore there are different signal attributes when you want to simulate the behavior of a photonic integrated circuit. There are no electrical connections or layers on top of each other that you can route and connect with vias. There are optical waveguides that transport the energy. And to keep this energy in those waveguides, you need curvy corners instead of just Manhattan 90-degree or sometimes 45 degrees corners that you see in electrical ICs. So for a designer, this means that traditionally this domain was managed by PhD in photonics that understood all the physics. Electrical models and simulators you can't use for photonic devices and circuits. Often we see people doing a kind of manual layout to overcome the requirements for the curves. And there are no, let's say, complete flows in the marketplace used that often yet, which result in low productivity for design and human error. When we look at the foundry that are fabricating those photonic ICs, we see that photonics processes and PDKs are not as mature as we're used to in CMOS electronics. And we also see that these curvy data and curvy shapes impact actually how you need to lay out to do optical proximity correction and mask data preparation to achieve the highest possible yield. So if you don't take care of those phenomena, you will be facing low performance and yield for your manufacturing. So having said that, Synopsys being active from silicon to software, Synopsys recognizing that photonics is a key enabling technology for future and current high-tech systems, and that there are different physics and requirements to design, simulate, analyze these photonic devices, systems, and integrated circuits, you can imagine that you require a portfolio of dedicated photonic design automation tools. And Synopsys offers three, let's say, product groups. One targeted towards photonic devices, like you could say TCAD in electronics. We have the Arsenal photonic device tools, which is industry's widest portfolio of physical level simulation and optimization techniques for photonic devices. We have Opsim to simulate the behavior of optical fiber-based and photonic systems. And then we have a portfolio of photonic IC solutions that help to capture the design intent, simulate and analyze the behavior, layout, and verify the layout before streaming out for manufacture. So let's dive deeper into photonic integrated circuit design. And when we look at the evolution of these software tools, going back to the end of the 1980s, early 1990s, where first publications were in the academic world about integrated optics, you saw that people, and especially in academia, were using homegrown tools to do some first order designs of these integrated optics devices. And in parallel, some commercial activity started to happen to develop dedicated photonic design automation tools. And as said earlier, mainly used by domain experts. And with the increased integration of more of these integrated optical components and a closer proximity of these photonics components with electronics and the, let's say, resurrection of using silicon as a platform in, say, 2005 onwards, we saw that also traditional IC designers started to become interested in this field, and they are used to electronic design automation tools. And what Synopsys is doing is bringing those PDA tools and EDA tools together to create a true electronic photonic design automation environment, helping also non-experts or traditional IC designers to be able to help design and help develop these photonic integrated circuit technology. So in our view, what we need to supply is an environment where we link photonic design automation capabilities with EDA methods and reduce or eliminate the need to customize tools or to have homegrown solutions or cobble together flows that allows for co-design of photonics and electronics and scales up to complete system design. So for that, Synopsys introduced Opto Compiler, which is built on proven photonic design automation technology. I just highlighted the RSoft photonic device tools, Opsim, and technology that we acquired from Phoenix Software, which was the company supplying Opto Designer as a layout and verification environment for integrated photonics. And bringing that together with trusted electronic design automation methods and tools that already existed within Synopsys to provide industry's only unified electronic photonic design automation platform. And that platform is built on a trusted analog and custom design solution, Custom Compiler, that is used by world's #1 mixed signal IP design team, that is having momentum in the market to, let's say, win new customers using this custom platform, because it is really very, let's say, targeted towards increasing productivity with a way, with faster layout capabilities, with automation and templates, and therefore having a closing cycle that is faster than what you see traditionally in this space. And that technology is used in the Opto Compiler platform. Together with our PrimeSim continuum, next generation circuit simulation technology, using very advanced SPICE and fast-SPICE algorithms that run on CPUs and on GPUs, and therefore unlocking the ability to solve problems that you can't with traditional SPICE or fast-SPICE algorithms. And in PrimeSim continuum, we bring together those engines in one unified workflow to provide differentiating electrical simulation technology in the market. And then with IC Validator, which is the Synopsys physical verification tool for DRC and LVS, that is used in more and more advanced nodes because of the performance and the flexibility of scaling towards the amount of compute power that you need for DRC or LVS, but also having capabilities specific to photonics DRC and photonics LVS. So these three building blocks from the EDA space at Synopsys, together with Opto Designer technology, with Opsim technology, with RSoft photonic device technology, resulted in industry's first unified electro-optical design platform. So we bring together the physical verification, the schematic capture and layout, the circuit simulation, both electrical as well as optical, and the ability to create photonic devices and optimize them with our photonic device compiler solution and the electrical equivalent Centaurus TCAD. And with that complete platform, we see customers achieving 20 times faster closure from initial design intent to verified layout that you can submit to a foundry or that you can manufacture in your own facilities. And what's really, let's say, interesting about this is the electro-optical co-simulation capability, where you leverage the PrimeSim continuum for the electrical part of the circuit, but also the capabilities of Opsim for the photonic parts of the circuit, and therefore yielding higher results and more accurate results when you simulate. An Opto Compiler is flavored with many specific photonic design productivity features to help you lay out these curvy, very sensitive structures faster than with any other solution. So Opto Compiler leverages a so-called schematic-driven layout flow, where you first capture a schematic by picking building blocks from PDK. You can simulate the schematic, and when you're satisfied with the schematic, you can move that to layout with all kinds of automation for abutment, for placing, for connecting. And then you can run layout versus schematic to validate that the layout is indeed still in close, let's say, accordance with the schematic. And you can back annotate from the layout into the schematic to re-simulate the behavior after you have laid out your circuit. And finally, when you're satisfied with that circle, you can do design rule checking and tape out. So to do that, we took the custom compiler platform and we enabled that with all the features from the Opto Designer environment, and included additional capabilities in the interactive cockpit so that you can recognize photonic devices, photonic wires in the schematic, that you can't per accidentally connect an electrical pin with a photonic pin. That in the layout you have seamless abutment under any angle, native support for curvilinear shapes. You can auto-generate those curvy connectors, either automatically or interactively by using, let's say, manual interaction on the layout canvas. And there is technology that helps you to not per accidentally connect waveguides of a different type when you're hooking up your complete circuit in the layout. And then Opsim. Opsim is our award-winning simulation solution where you can simulate photonic communication systems, really fiber-based systems or free space optical systems like LiDAR, but also photonic integrated circuits, where it's really important that you are able to incorporate reflections because the sizes are now so small so that light can easily propagate back and forth and interfere actually with the signal propagation, supporting multiple wavelengths traveling through these circuits at the same time and being able to identify wavelength mixing or dispersion. And again, you see here in this schematic capture that we have electrical signals recognized here in blue, data streams or digital or logical signals in green, and photonic signals in orange. And you can really create your own complete system or circuit schematic with Opto compiler, and Opsim can simulate the behavior of this circuit, leveraging PrimeSim in case you also incorporate electrical devices. And to analyze the results, the solution is integrated with PrimeWave, and this provides all the domain-specific analysis that you need for photonic integrated circuit design and analysis. And then Photonic Device Compiler, which is built around the RSoft photonic device portfolio with industry's largest set of tools for optimizing, simulating, and designing passive and active photonic devices, using methods like beam propagation method or FDTD or RCWA to really solve the problem with the algorithm that is most suitable to solve that particular problem. And then these device tools are integrated with Centaurus TCAD, the industry leading solution for electrical device design and optimization, so that you can really create very complex active photonic devices like modulators or detectors, and simulate the electrical and photonic properties in one integrated environment. And then on top of that, we created all kinds of automation to take results either from these simulations and automatically turn these results into compact models for simulation in Opsim, in symbols for the schematic capture in Opto compiler, for layout information to do the layout with Opto compiler, and LVS information to allow also for LVS with IC Validator. Or if you start with an existing device with measured data from manufactured silicon, we have technology to take, again, existing GDS information or existing P-cell information together with measured data and turn that again into model data, symbols, layout, and LVS views to use in the context of the Opto compiler platform. And where in the industry PDKs are being built by foundries, we still see a need for custom design in this space. And this photonic device compiler solution allows designers to do custom design in the context of a given foundry PDK. So a really powerful addition to opto compiler and Opsim as the photonic integrated circuit design platform. So as mentioned, Synopsys believes in photonics everywhere, and therefore we feel a need to help the industry and the ecosystem to accelerate adoption by providing tools and services. As said, we launched the opto compiler some time ago now, and with that we see customers being successfully shortening their turnaround time and introducing more products into the market. But we also work with universities and research consortia to more or less educate the workforce of the future. And we collaborate with foundries to make sure that PDKs are available to access this technology. And we believe that with all the technology that we have here at Synopsys, both photonics and electronics, with a history going back to the early 90s of our team, and already supported more than 1,500 photonic tapeouts over the last 10 years with our technology, that we are in a great position to help this industry to further adopt photonic integrated circuit technology. And just 2 customer testimonials to more or less allow us to say something about the claim that we can really help reduce turnaround times. This is a quote from Radha Nagarajan, CTO at Inphi, now part of Marvell, where they could reduce the time from schematic entry to final test chip layout by nearly 4x over their legacy tools that they used in-house. And Andrew Rickman, CEO at Rockley Photonics, really, let's say, is very thankful to Synopsys by providing the opto compiler platform for their adventure that resulted in their recent IPO, where they could just faster define and simulate a layout and verify photonic ICs to meet their, let's say, very tight schedules in their development cycles. So as mentioned, we also work with universities and with consortia because we believe that this industry still needs help, and Synopsys continues to support road mapping and helping pilot lines or consortia to develop next generation technology platforms. So projects like AIM Photonics in the United States, or PIX for Life and PIXAP and MIRFAB and the JEPIX pilot line in Europe, but also the IPSRI Silicon Photonics and Integrated Photonics Roadmap are projects that we actively participate and support to help the ecosystem. And we work with Europractice in Europe, or AIM Academy in the United States, or MIT and NARLabs in Taiwan to help set up training programs and access to licenses for education. Again, just to help the industry to create a larger ecosystem that is able to leverage this technology to solve these society needs for the future. And finally, while this technology, and we heard more about that earlier today, is moving really into volume manufacturing, we are collaborating with all major foundries around the globe to make sure that there are mature PDKs for the opto compiler platform to be able to design and simulate and lay out and verify photonic ICs like traditional CMOS designers are used to. So while we continue to help the so-called boutique foundries in the R&D ecosystem, we also are heavily engaged with the tier 1 and tier 2 foundries to make sure that we enable PDKs for our mutual customers. So with that said about the Synopsys Photonics EO co-design platform, I want to draw your attention again to tomorrow, where my colleague Louis Orbe will go way deeper into all the capabilities of the opto compiler platform, of Photonic device compiler, Opsim, and IC Validator, and also discussing some actually, let's say, measured photonic ICs from Towie Semiconductor to show you how you can leverage the technology I just described to your benefit to improve your design cycle for photonic integrated circuits. So I highly recommend it to join tomorrow morning again, 8 a.m. Pacific, and learn from Louis firsthand how you can leverage these tools. And with that, I'd like to thank you for your attention today. I'd like to thank you all for joining and participating, and looking forward to meet you in the chat or to see you again tomorrow when Louis will do the deep dive in the platform. Thank you very much, and bye-bye.